All right, so before we get into even solving these questions, let's talk about the properties of a parallelogram. Who can give me one of the 5 properties of a parallelogram? Yep.
So opposite sides are congruent.
Opposite sides are congruent. Opposite angles are congruent.
If the angles are like on the same side, they add up to 180.
Okay, consecutive angles are supplementary.
Opposite sides are parallel.
Opposite sides are parallel. Missing one.
Is it the one with the, if it's like the diagonal?
Mm-hmm. What is it? Diagonals. What?
Then the two, like the two, they're like two.
Good, they bisect each other. Diagonals bisect each other.
Which means they're equal to each
It
other.
means they cut each other into equal parts. So the whole diagonal is not necessarily equal. The whole diagonal is not necessarily equal, but the 2 parts along each one are. All right, so number 1 says find the values of A and B in the parallelogram. So if I wanted to solve for A is one of the sides, right, or it's on one of the sides. So I can say A minus 12 equals 30. And A would be 42. And then B is on the angles. B plus 10 would equal 36. Good. B equals 26. Good so far? Okay. Then number 2 says find the measure of K in the parallelogram. So if L is here, and what's the relationship between L and K? They're supplementary. So 180 minus 64 gives you 116. Good. So if you knew one of the angles in the parallelogram, you should be able to get all 4, because that would be 116, as would that, and that would be 64. So one angle in the parallelogram, you can get to all of them.
Quiz is Thursday.
Correct. All right, then it says find the indicated measures in the parallelogram A, B, C, D. So number 3 is at angle BCD. BCD is this whole angle here. How could I find it? Good. So this, Mateo said, the alternate interior, right? That's 37. This is 100. And then Geo, so that means that these are 137. And if I did 137 from 180, you get 43 is that whole angle there, which is what it's asking for in the first one. I don't know individually what these are or these are. Okay, I'd have to have a little bit more information than that. But I do have at least the overall big angle that's there. And then it says if BE is 9, find BD. We said that what's true about these diagonals? Good, they bisect each other. So if that's 9, then this is 9, and the whole diagonal would be 18. Good. And then the last one's just like the question that we did. Yeah, and then my bad, I should have taken that side off. Good? Are we good? We already did this one. We did this one yesterday. Okay, so before we get into notes, your quiz, and I'm going to put it in quotations, on Thursday, just so you can kind of like prepare for it, is going to be actually counted as a classwork assignment because, yeah. So,
Wait, what?
Miss Court, well, we're going to get the quiz, like I'll give it to you, like it's a piece of paper, here's your quiz, right? But it's only going to count for a classwork grade. Does that make sense?
Also, you're not thinking of another quiz.
Yeah, we actually luckily had enough to get 4 in before the quarter anyways. We were going to bump that 4th to count to the 4th quarter, but it worked itself out. Yeah, stuff happens, and you get to be flexible, right? It's not the big of a deal. So it's important for you to be reviewing because we're at the halfway point, and this, you want to know what you know up to this point, because obviously if you wait to only practice before your test, it's a lot harder, but this will only count as a classwork grade. Good news is that we flipped them today. It's the converse. It's the converse of everything we talked about in A2. So in A2 we said if it's a parallelogram, then those 5 things are true. And now we're saying the reverse.
Will this also be on the quiz?
Yes.
Okay.
So this first one says, and again, number not important. It says theorem 8.7, not important. What it's important is what it says. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So yesterday we said if it's a parallelogram, both pairs of opposite sides are congruent. Now we're saying the reverse or the converse of that. If both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So if I was looking at this shape, I would say because AB equals CD and BC equals AD, then it's a parallelogram. ABCD is a parallelogram.
Is there a name for this?
No.
So when they ask, like they want to ask me, like,
If it asks you to explain why, you would just say if both pairs of opposite sides are congruent, then it's a parallelogram. So you can shorthand it as much as you want, but you don't need, you won't use the number. Yep. Well, justifying a little bit, yeah.
Is there a specific way, like, you would read it? Because, like, sometimes, like the letters are arranged kind of which directions.
The name of it, you mean?
Yeah.
Like the name of the parallelogram? As long as you go in order clockwise or counterclockwise, it doesn't matter. So you could call that B, C, D, A, C, D, A, B. None of that matters. Or go back the other way. You just can't say like B, D, C, A. Like you can't jump across. But if you go clockwise or counterclockwise, you could call it anything you want. All right, next one is if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So for this one, because angle B is equal to angle D and angle A is equal to angle C, A, B, C, D is a parallelogram. Okay, next one. If one pair of opposite sides is both parallel and congruent. So instead of them, both pairs of opposite having to be parallel or both pairs of opposite having to be congruent, if the same side is marked as parallel and congruent, then it's also a parallelogram. All right, and the last one says if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if those two diagonals are cut and each one is cut into two congruent parts, then it's a parallelogram. All right, so notice that we just went through 4 theorems, right? But this says there's 5 ways to prove that a quadrilateral is a parallelogram because the first one is the definition. So this didn't need to be a theorem because this is the definition of a parallelogram. If both pairs are parallel, then obviously it's a parallelogram. That's the definition of a parallelogram. If both pairs are congruent, if both pairs of opposite sides are congruent, then it's a parallelogram. If one pair are parallel and congruent, if both pairs of opposite angles are congruent, and the diagonals bisect each other. So this is your 5 ways, just like there's 5 properties, there's 5 ways to prove that something is a parallelogram. This is just the same thing, just with visuals. So the first one, definition, and then these are the numbers. But again, I don't ever want you to give me the number. I don't know if the homework asks for it. But on a quiz or a test, if you're trying to justify something, you'll write it out instead of giving me the number. So both pairs are congruent, both pairs opposite sides, both pairs opposite angles. One pair opposite sides are congruent and parallel, and then diagonals bisect here. All right, here's some application.
Would we have like a proof for like a chapter test?
Test we haven't made yet. Quiz, there is one on there. Yeah, it's like a baby proof. It's like a 3-step, half filled in, but it's a proof, yeah. All right, this says state the principal definition or theorem that enables you to deduce from the given info that the quadrilateral is a parallelogram. So if I look at number 1 and I want to mark BE is equal to ED and CE is equal to EA, is it a parallelogram?
Yes.
And how do you know that?
Because the diagonals bisect each other.
Good. Diagonals bisect each other. So in big formal wording, it's if diagonals bisect each other, then it's a parallelogram. We know what we're proving, so you can give me that. 2 says angle BAD is equal to angle DCB, and ADC is congruent to CBA. Is this a parallelogram?
Yes.
Yes.
And why?
Opposite angles.
Good. Opposite angles are congruent. BC is parallel to AD and AB is parallel to DC.
Yes.
Yes, and why?
Opposite sides are parallel.
Definition, this is the only one that you can use a name. Definition of parallelogram or opposite sides are parallel. So you can use either one.
This is like a proof.
Like if you could use this in a proof, this would be one of the ways you could use it in a proof. Okay, then comes BC is congruent to AD, and AB is congruent to DC.
This is opposite sides or?
Good, opposite sides are congruent. Oh, that last one should have been marked. I marked them as congruent, but they should have been parallel. And the last one says BC is equal to AD and BC is parallel to AD.
If one pair of sides are congruent and parallel, then it's parallel.
Good. One pair congruent and parallel. So it has to be the same pair. You can have one pair be marked as congruent and one pair be marked as parallel. So homework is a lot of application of this. I think. All right, so if you're looking at it, obviously the first ones are like what theorem can you use, which is just like the examples we just worked through. If you look at 8, 9, and 10, it says for what value x is the quadrilateral parallelogram. So you need to figure out what kind of information is given to you and then figure out, should they have to be marked as equal? Do they have to be, like that kind of stuff. So if I look at 8, if these two are equal, then these two would have to be equal in order for it to be a parallelogram. Does that make sense? Set it equal, figure out your value for x. I'll work through 11 with you because this is one of your coordinate plane ones, right? So it says the vertices of quadrilateral A, B, C, D are given. Draw A, B, C, D in a coordinate plane and show that it's a parallelogram. So I'm going to actually pull in a coordinate plane. I'm going to plot these points. So A is 0, 1. B is 4, 4. C is 12, 4. And D is 8, 1. With me so far? This was C, this was D. So first of all, can I just say it looks like it's a parallelogram, so it's a parallelogram? No. Okay. Remember, we're smarter than that. We have to figure it out by more definitive information. So what are some ways that we could do this? Because there could be more than one. I could say that again.
Find the lengths of the opposite sides.
I could find the lengths of the opposite sides, and if this is congruent to this and this is congruent to this, then it's a parallelogram, right? What else could I do? But that's super hard, right?
Find the slopes, if they're, the slopes are
I could find the slopes of both lines, and if the slopes are equal, then they're a parallelogram. Or just find one of each, right? Pick one side, find the slope, and find the length. Which one do you think that's going to be easier to do?
AD and BC.
Yeah, the horizontal ones, right? What's the slope of a horizontal line? 0. Okay, how about the distance between those 2 points? I could just count it. 1, 2, 3, 4, 5, 6, 7, 8. What do we go to 10? 10 minus 4. This is 8. This is 8. So just that alone shows that the opposite sides are parallel and congruent. You with me? If it's slanted, okay, if they're not parallel, which is like number, oh no, those are 2, I think. Let's say it's slanted, then you would have to find the slopes and the distance. Probably the easiest way is just pick one pair of sides, find the slopes, and find the distance, okay? Or both pairs of slopes, something like that. So if you're trying to prove both pairs of sides have to have the same slope. Okay, or both pairs of sides have the same length, or one pair has, yep, same slope and length. So for 12, I expect to see it plotted on a coordinate grid, okay, and then you figure it out from there.